Good evening, students. This is Venugopal from ThoughtFlow Institution. Today, let us discuss with a chapter called as Solid State. When it comes to CET, from solid state, we may expect one or two questions. When it comes to NEET, there is no weightage for this particular chapter. Now, let us analyze with certain major synopsis of the chapter Solid State. The first and the foremost thing that has to be known is the different types related to solids. There are 4 different types related to solids called as ionic solids. The second type is called as covalent solids. The third type is called as metallic solids. And the fourth type is considered as the network solids. Next to this, we should know the meaning known as anisotropic as well as isotropic in its nature. So, anisotropy is a property in which the substance exhibit variations in its properties when we move in different directions. Whereas in isotropy, the properties will remain the same. And the third one is called as unit cell. We know that the unit cell is considered as the smallest repeating unit of a crystal lattice. Means if this unit cell is repeatedly placed continuously, it gives rise to a crystal lattice. So this is the representation of an unit cell, where this unit cell consists of 8 corners present in it, where the contribution from each corner is 1/8 part of it. When it comes to simple cubic consists of 1 particle present in it. With reference to BCC, it consists of 2 particles present in it, where 1 particle will be exactly present at the body center and 1 particle will be contributed from the corners. In the same way, FCC consists of 4 particles present in it, where 3 particles will be obtained from the faces and 1 particle will be obtained from the corners. And the next concept in solid state is coordination number. And when we discuss with coordination number, it explains about the nearest neighbors that are associated with a particular particle is known as coordination number. If I consider an example, suppose if I mark this particle with an asterisk mark, the neighboring particles for this respective particle is 2. Hence, the coordination number for this is 2. In the same way, simple cubic crystal system consists of a coordination number of 6. BCC consists of a coordination number 8, which can be remembered as B as second alphabet, C as third alphabet, plus one more C as third alphabet. When we sum up this, we get a coordination number 8. In the same way, FCC has a coordination number of 12, where F is the 6th alphabet, C is the 3rd alphabet, and one more C is the 3rd alphabet. If we add up together, we get the coordination number as 12 with reference to FCC. Next to this, a concept known as packing efficiency. When it comes to packing efficiency, sometimes this packing efficiency can also be asked as packing fraction. With reference to simple cubic, 54% is the packing efficiency and its fraction is 0.54. With reference to BCC, packing efficiency is 68% and the packing fraction is 0.68. And with reference to FCC, the packing efficiency is 74% and the packing fraction is 0.74. After knowing this, let us analyze the relationship between the radius R and the edge length A. When we go through with this relationship for SC, BCC as well as for FCC, the relationship between radius and the edge length can be represented as R is equal to A by 2 with reference to SC, and R is equal to root 3 by 4 into A with reference to BCC, and R is equal to A divided by 2 root 2 with reference to FCC. After this, one should have an idea related to defects in the crystal system. And here we should be familiar with reference to defects called as Schottky defect, Fresnel defect, as well as a metal excess defect and the metal deficiency defect. In this concept, we can expect the questions from Schottky defect as well as Frenkel defect. Next to this, we should know the concept of magnetic moment, where this magnetic moment is represented by a notation called as mu, which is given by the formula square root of n into n plus 2, where n is the number of unpaired electrons and it is measured by an unit called as Bohr magnetron. And one should know the concept related to band theory of solids. When we study with band theory of solids, this explains about the variations in its conductivity ranges for conductors, semiconductors, as well as insulators, which explains the forbidden energy gap between the valence band as well as the conduction band. And here, with reference to semiconductors, again we should know two different types of semiconductors called as p-type semiconductors as well as n-type semiconductors. With reference to p-type and n-type semiconductors, in an p-type semiconductor a trivalent impurity is added, whereas in an n-type semiconductor a pentavalent impurity is added. And the last concept with reference to magnetic property has to be known, which explains with relevance to diamagnetic property, a paramagnetic property, a ferromagnetic property, ferrimagnetic property, as well as anti-ferromagnetic property. These are certain concepts that has to be known from the chapter solid state.